Hi everybody. Just wanted to give you guys a couple more pointers on graphing parabolas in Vertex and factored form before we take the quiz tomorrow. I'd like you guys to do a little more practice. I kind of came up with a lot of this based upon what I saw you guys doing on the practice test on Friday. So I know that that was really helpful for a lot of you guys. It was also really helpful for me to see what you guys are doing well at, such as finding the vertex, finding the zeros. Um, Solving for A is actually doing really, you guys are doing really good at. And then some things that you still need a little more help with, such as just plotting other points that are not the obvious ones like the vertex or the x-intercepts. So I'm going to help you guys with that today. So on the quiz on tomorrow, you're going to have a lot of questions that look like this. And it's going to say write the equation or find these points, but you don't always need to graph the entire thing. Um, but we're just going to make sure we know how to graph the entire thing, because then you'll be set. If you can graph everything and write the equation, you'll be perfectly set for tomorrow. So number one here is you have a parabolic function, has its vertex at -2, 4, and it has its y-intercept at 0, 3. So since we have the vertex, we're going to write this in vertex form. So before I do that, I'm going to just plot these points. So I have my vertex at -2, 4, -2, 4 right here. And I have a y-intercept at 0, 3, which is right there. So right now I only have 2 points. One thing I would like you guys to always do is to draw in the axis of symmetry. You can just do a dotted line. It's really hard for me to do a straight line on here. Axis of symmetry. This should cut your work in half because hopefully you guys can see I have this point here that they gave me for free, but I also have its reflection over here because a parabola is symmetrical. So I'm already 3 out of 5 points down. I'm almost done graphing this thing. I'm going to need to write the equation to graph the rest of this. So again, we're doing this in vertex form. So y equals a, there's always an a, x, well, since this is in vertex form, let's think about the transformations on the parent function. I think you guys can already tell it's upside down, but that'll be part of our a. How does its vertex move? Well, vertex moved 2 to the left. So I'm going to write x plus 2 squared. Remember that the left-right is always backwards and it's in the parentheses. So it's plus 2 to go left. And then it's moved up 4. So that's as good as I can write it right now just based upon the vertex. Now we're going to solve for a. And the way that we solve for a is we're going to use this extra point that they gave us. They always give us an extra point. And I'm going to plug that x and y in to this x and y. So I'm going to write 3 equals a times 0 plus 2 squared plus 4. So I get 3 equals a times, this is always times, probably just save us some time here. This is 2 squared, which is 4 plus 4. Huge mistake that I saw a lot of people making is they would add these numbers together and then multiply. That obviously is not right because we know our order of operations, multiplication comes first. So I'm just going to get rid of this plus 4 by subtracting it from both sides. And I get -1 equals a times 4. Or if you like, you could write 4a, which is how we normally see it. I'm going to divide both sides by 4. And we get a equals -1/4. And then since we have a eraser, we'll just go erase this a value because we know what it is now. It's negative a fourth. So now I can use this equation to graph my other points. So two ways we could get these other points. We know the steepness now. We know it's upside down, obviously. We know it opens downwards. We also know that it's a quarter as steep as the parent function. And I think we can confirm that because normally a parabola that opens downwards that has the regular steepness would go right to down 4. But this one goes right to down 1. It goes down a fourth of 4. So this fourth is right. So I can get this last point pretty easily because I know it normally goes right 1 down 1, but now it's going to go right 1 down a fourth of 1. And we have that point, and now we have that point. So this is a pretty wide parabola. I also want to show you guys one more way to get a point, because I know a lot of people aren't necessarily comfortable using this steepness, this a value here, to plot the points. And what they can do instead is they could just write out the equation and find the points that way. So we got y equals negative a fourth times x plus 2 squared plus 4. Well, let's say that 5 points wasn't enough. Say I wanted a 6 point. So let's say my 6 point, let's think of an easy number to put in. That'd be 1. That's right here. What is y when x is 1? Well, I'm just going to put 1 in for x. We know we have some point on this vertical line here. It's 1 comma something. How do we find what the y value is? We just plug it in here. So we get y equals negative a fourth times my x is 1 plus 2 squared plus 4. Erase this. So I can already tell that this is not going to be very nice numbers. So y equals negative a fourth times 1 plus 2 is 3. 3 squared is 9. So negative a fourth times 9 plus 4. So negative a fourth times 9 is negative 9 fourths. I could write plus 4, but I know I need a common denominator. So 4 is really 16 fourths. You guys could also do this on your calculator if you want, but be careful with the order of operations. Make sure your answer makes sense. Make sure your points make sense. So negative 9 fourths plus 16 fourths is y equals 7 fourths. So that's really 1.75. So I know when x is 1, y is 1.75, which is about right there, which pretty much lines up well with what we already had going. So that's good. So that's a second way you can find a point. You can find any point that way, so no excuses. All right, so let's look at one in Vertex factored form, sorry. We have an equation for a parabola. Its equation is y equals a half times x minus 2 times x plus 2. What are the coordinates of the parabola's x-intercepts? So we know x-intercepts are always, they're on this line right here. It's where y is 0. Most people are doing pretty well at figuring out what these are from an equation or writing the equation given the intercepts. Well, what would make this binomial 0? That would be if x was negative 2. What would make this binomial if x was 2? You're just looking for what makes each binomial 0. So let's go ahead and plot those points. So we got 2, 0, negative 2, 0. The y-intercept. Well, this isn't in standard form, which I think most of you guys are happy about. So, but the problem is we don't have the y-intercept. So we'll save that. The vertex, we don't really know the vertex either because this isn't in vertex form. So what can we do? Well, what I would suggest is always find the axis of symmetry. The axis of symmetry is always halfway between your x-intercepts. So I'm just going to dot that in. So it just so happens that our axis of symmetry is on our y-axis. That rarely happens. So just beware of that. It's not always on the y-axis. So let's see here. I think we're going to have to write the equation next. So, sorry, not write the equation. We're going to have to evaluate for some points. So what if I put 0? What if I want to find how high, what the y value is when x is 0? I'm just going to put 0 into this equation. So I'm going to get y equals 0.5 times 0 minus 2 times 0 plus 2. So that becomes y equals 0.5 times negative 2 times 2. 2 times negative 2 is negative 4. Negative 4 times a half is negative 2. So when x is 0, y is negative 2. So now we have a point. We actually have our vertex. 0, negative 2. It just so happens it's also our y-intercept. Again, this rarely happens. Usually our y-intercept is different than our vertex, kind of like in the previous problem. This was our y-intercept. That's our vertex. They're rarely the same thing. And then we want to find out one more point. We want to find out, I would probably put in 1. So what you could do is you could put x equals 1 into this equation here and figure out what y is. Just evaluate it for y. Or if you like to use the steepness instead, remember our steepness is right here. It's a half. So we know a normal parabola, the parent function, goes right 1, up 1. But this one goes up slower. It's going to go up right 1, up half of 1. Because it normally goes up 1. It's going to go up half of 1. Its twin is right over there. We can double check that here. A parabola parent function normally goes right 2, up 4. But this one goes up half as fast. It goes right 2, up 2. So we can always double check it that way. And that should be enough points to graph our parabola. Remember, you only need 5 points. Don't just give up just because not all of them are super, super easy. The x-intercepts are always easy when it's in factored form, and the vertex is always easy when it's in vertex form. But other than that, you'll have to do some thinking. Use your axis of symmetry. Anytime you find 1 point, you should find 2 points pretty easily by reflection. You guys have a nice day. I'll see you tomorrow.